Hello guys, welcome to my channel No Tension Programming. Today we learn about encapsulation. Encapsulation is a fundamental concept in object-oriented programming, OOP, where data, attributes, and methods that operate on the data are bundled together within a class. This bundling helps to hide the internal state of an object from the outside world and only exposes the necessary functionalities. In simpler terms, encapsulation is like wrapping up an object in a box. You can interact with it through predefined channels, methods, but you can't directly access or modify its internal data without going through those channels. This promotes data integrity, security, and helps manage complexity in larger software systems. Here are some key points about encapsulation. 1. Data hiding. Encapsulation allows the internal state of an object to be hidden from the outside world. This means that the implementation details of an object's data are kept private and cannot be accessed directly from outside the class. 2. Access control. Encapsulation enables control over how data is accessed and modified by providing public methods, interfaces, to interact with the object's data. These methods serve as gateways for accessing or modifying the internal state, allowing the class to enforce rules and constraints. 3. Information hiding. Encapsulation promotes information hiding by exposing only the necessary details of an object's behavior while hiding the rest. This helps to reduce complexity and minimize dependencies between different parts of a program. 4. Modularity. Encapsulation encourages modular design by grouping related data and behavior together within a class. This makes it easier to understand, maintain, and reuse code, as each class encapsulates a specific functionality or concept. 5. Enhanced security. Encapsulation helps to protect data integrity and prevent unauthorized access or manipulation of an object's internal state. By restricting direct access to data and providing controlled interfaces, encapsulation reduces the risk of unintended side effects and enhances security. 6. Abstraction. Encapsulation supports abstraction by allowing objects to present a simplified view of their functionality to the outside world. Clients interacting with an object only need to know how to use its public methods, without needing to understand the underlying implementation details. 7. Encapsulation versus encapsulation. Encapsulation is often used interchangeably with the term information hiding, but they are not exactly the same. Encapsulation refers to the bundling of data and methods within a class, while information hiding specifically focuses on hiding the internal details of an object's implementation. Overall, encapsulation is a powerful concept in object-oriented programming that promotes modular, secure, and maintainable code by encapsulating data and behavior within well-defined boundaries. Real-life example of encapsulation. Let's consider a real-life example of encapsulation using a car as an analogy. Imagine you're driving a car. From the driver's perspective, you interact with the car through its interface, the steering wheel, pedals, and dashboard controls. You don't need to know the intricate details of how the engine, transmission, or braking system work internally. You just need to know how to use these controls to operate the car safely and efficiently. Here's how this example demonstrates encapsulation. 1. Data hiding. Just like how the internal components of the car, engine, transmission, etc., are hidden from the driver, the internal state of an object is hidden from external code in encapsulation. In the case of the car, you don't need to know the exact RPM of the engine or the temperature of the transmission fluid to drive the car effectively. 2. Access control. In a car, certain controls are accessible to the driver, steering wheel, pedals, while others are not, engine internals, electronic control units. Similarly, in encapsulation, access to an object's internal state is controlled through methods and interfaces. You can't directly access or modify the internal state of an object. You have to use the provided methods to interact with it. 3. Modularity. A car is a modular system composed of various components, engine, transmission, brakes, that work together to perform a specific function, transportation. Similarly, encapsulation promotes modularity by grouping related data and behavior within a class. Each class represents a modular unit that encapsulates a specific functionality or concept. 4. Abstraction. As a driver, you don't need to understand the intricate details of how the car's engine or transmission work internally. You only need to know how to operate the controls effectively. This is similar to abstraction in encapsulation, where the internal implementation details of an object are hidden and only the essential functionalities are exposed through interfaces. By using the analogy of a car, we can understand how encapsulation works in real-life scenarios, promoting modularity, abstraction, and controlled access to an object's internal state.